Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see the topic about Bayesian inference. Objective to understand about the concept of Bayesian inference and to understand how to apply the probability concept in the inference. In Bayesian inference, first we see what is the probabilistic reasoning. We apply the concept of probability to indicate the uncertainty in the knowledge. The probabilistic reasoning is the combination of probability theory and the uncertainty. We use probability in the probabilistic reasoning because it provides a way to handle the uncertainty. So what is uncertainty? It will rain today. Behavior of someone for some situations. A match between two teams or two players. There are probable sentence for which we can assume that it will happen but not sure about it. So here we use probabilistic reasoning. Need of probabilistic reasoning in AI. When there are unpredictable outcomes, when specifications or probabilities of predictors becomes too large to handle, when an unknown error occurs during an experiment. Ways to solve problems. In probabilistic reasoning, there are two ways to solve the problems with uncertain knowledge: Bayes rule and Bayesian statistics. Probability. Probability can be defined as the chance that an uncertain event will occur. The value of probability always between the 0 and 1, that is 0 less than or equal to P of A less than or equal to 1, where P of A is the probability of event A. Uncertainty in the event is A, then P of A equal to 0. When uncertainty of the event is certainty in the event is A, then P of A equal to 1. We can find the probability of uncertain event by using the formula, that is probability of occurrence is equal to number of desired outcomes divided by total number of outcomes. Let's see about the conditional probability. Probability of occurring an event when another event has already happened. Let us suppose we want to calculate the event A when event B has already occurred, then the probability of A under the conditions B, it can be written as P of A bar B equal to P of A into B divided by P of B, where P of A into B equal to the joint probability of A and B, and P of B is the marginal probability of B. So this is the examples for the probability problems. Next, Bayesian reasoning. So Bayes theorem is also known as the Bayes rule, Bayes law, or Bayesian reasoning, which determines the probability of an event with certain knowledge. So in probability theory, it relates the conditional probability and the marginal probability of two random events. Bayes theorem was named after the British mathematician Thomas Bayes. The Bayesian inference is an application of Bayes theorem which is fundamental to the Bayesian statistics. It is a way to calculate the value of P of A bar B and with the knowledge of P of A bar B. Bayes theorem allows updating the probability prediction of an event by observing new information of the real world. Example, if cancer corresponds to one's age, then by using Bayes theorem, we can determine the probability of cancer more accurately with the help of age. Bayes theorem can be derived using product rule and conditional probability of event A with known event B. As from product rule, we can write P of A into B equal to P of A bar B into P of B are similarly the probability of event B with the known event A, then P of A into B equal to P of B by A into B of A. Equating both right side, we will get P of A bar B is equal to P of B bar A into P of A divided by P of B. The above equation is called Bayes rule or the Bayesian theorem. This equation is basic of the most modern AI system for probabilistic inference. It shows the simple relationship between the joint and conditional probabilities. Here P of A bar B is known as posterior, which we need to calculate, and it will be read as probability of hypothesis A when we have acquired an evidence B. P of B bar A is called likelihood, in which we consider that hypothesis is true, then we calculate the probability of evidence. P of A is called the period probability of hypothesis before considering the evidence. P of B is called marginal probability, pure probability of the evidence. In the above equation, in general, we can write P of B equal to P of A into P of B by AI. Hence, Bayes rule can be written as P of AI by B is equal to P of AI, P of B bar AI divided by summation I equal to 0 to K P of AI into P of B by AI. Application of Bayes theorem. Application, it is used to calculate the next step of the robot when the already executed step is given, and Bayes theorem is helpful in weather forecasting. It can solve the monthly halt problem. Thank you.